Hello and welcome to API security. We talk about how to secure APIs nowadays. And let me start with a small introduction here. So typical questions would be, how many APIs do you have? Normally, most of our customers cannot answer that. They come up with answers between a few hundred, a few thousand, even sometimes with a few 10,000s of APIs. So looks like visibility is missing for most of our customers. Next question would be, how convenient do you find it to manage your APIs? Again, it's a tricky question. Most of our customers don't find it very convenient because we started with not having visibility, and then managing it means you have to find it, you have to find the flaws and work on the flaws and don't know if you missed anything. So most people don't find it very convenient to manage APIs. And do you think your APIs are well secured? Well, again, most of our customers don't think that their APIs are well secured. Problem here is, since you don't know what is happening, you don't know if they are well secured or if they are abused for something. So let's take a look on the attack surface that connects us all. My name is Stefan Mardak. I'm working with Akamai as an enterprise security architect in a principal level. The average number of applications per enterprise is more than 1,000. And if you think about applications, they are not standalone applications. They are talking to each other. They are talking to the outside world, and the outside world is talking to them. And all of these connections between APIs and, between applications and the APIs is mostly done by APIs. So API is exchanging data between services, between servers, but also between smartphones, mobiles, laptops, etc. So this is the glue that connects all of our world right now. The API security environment is not like the web environment. So we have done a lot to secure web services. If you go to a website, it's secured, but APIs are different. We see about a third of the web traffic on our platform are APIs. And if you think about Akamai, then we transport around 300 terabits of data per second. This is the biggest content delivery network in the world. And as I said, a third of that is web traffic. By the way, that web security has done its job. You can see that by the exploding numbers of social engineering. So you get this scream calls, or somebody's calling you and requesting money from you. This is all because web security is pretty good nowadays. But the other part is APIs. More and more hackers are concentrating on APIs because what we already have set up for web security doesn't work for API security. It's a different use case. It's a different traffic that we are seeing, and it needs to be secured in a different way. And this is why we assume that year by year, the API abuse and related data breaches will probably double. So expect to see more about broken APIs. The typical landscape inside a company or inside an organization is you have different APIs talking to each other. You have business units talking to each other, and all of that inside the organization is done by APIs. We call this API talks east-west traffic. So it's inside the environment, and it should be secured. And it should be secure to that one application talks to the other. But with the upcoming of zero trust, it's not like that. There can be a server that is infected, and then it's talking to the rest of the services. So it might make sense to also look into or east-west traffic, so the API traffic inside your company. The other part is north-south traffic. So this is coming from partner APIs, B2B. So they are mostly authenticated, should be good. But there is also B2C. So your customers are coming in using websites or coming from mobile apps. This is how it should be protected today. So this is a setup that we are using within Akamai. Obviously, we secure against the known threat protection. We protect against the known threats, which is bot mitigation, web application firewall, etc. On the right-hand side, you see we also have DDoS protection, which includes securing DNS, which includes infrastructure protection, like DDoS mitigation of packet floods against your data center. We also provide cloud security with the software gateway that checks data for HTTPS data for your environment. And what is left over is the entry to your APIs by using an API gateway. This API gateway does authentication and authorization, and everybody going through your servers is authenticated and authorized to do so. And in theory, that should be enough. In practice, we see a lot of account takeovers. We see fraud and business logic abuse and other things where somebody took over a connectivity or somebody is misusing the connection that is having. And an API gateway cannot help against that. Reason for that is if you take a look on OWASP top 10, if you're in security, then you know the OWASP top 10 security risks for web traffic. We now have the same for API traffic. And if you compare it to each other, then authentication, number 2, API 2, API 2 is broken authentication. That is something that API gateway can help against. But if you take a look on broken object level authorization, then it's really tough to do something like that on an API gateway. And if you take a deeper look, then unrestricted access to sensitive business flows, that's a configuration issue, and you cannot find this with an API. And if somebody found out that there is a misconfiguration and is misusing it, you will never see it because you don't look into how the API behaves. So today's problems are to discover shadow APIs. Most of our customers, most of the companies are able to do so. So they try to discover the complete API footprint. But with my initial statement, you don't know how many APIs you have. You have a severe problem to find all of the APIs. Think about APIs that get a new version of the APIs. So it's spin up, and then you have 2 versions of the API up and running. For compliance reasons, the first one should stay another 3 months, and then it should be brought down. But in the meantime, the administrator changes, has new roles or a lot to do, so he keeps forgetting about that. So you have shadow APIs that are not documented, so they shouldn't be there, but they are there. Then on vulnerable APIs, think about payment data. Payment data should be encrypted, and you never find out if an API is using not using encryption, but is providing data for payments. So that's a more tricky one to find. And the last one, the third one, detect API abuse. This cannot be done in normal circumstances because to detect API abuse, you need to understand the behavior of the API. So you need a timeline. So you need historical data, in the best sense for some weeks or even for a complete month, and then analyze it and look inside what is happening. So today's focus is more on the left side, discover shadow APIs, perhaps on determine vulnerable APIs, but actually it should be on the right-hand side, because if you take a look on headlines in the newspapers, you see a lot of fraud going on, and that is using API by abusing APIs, even if you're authenticated. So our idea has been to reinvent API security in the sense that we are looking for shadow APIs by doing a continuous API discovery. We are seeing the traffic inside your data center. Actually, you make it happen. We provide we provide something that can see all your data, check for the contents, and then gives back a complete insight into all of your APIs. So with that part, the question, how many APIs do you have, can be completely answered. At the same time, when looking into the APIs, it can do a risk audit, and it looks for posture alerts. So it would find encrypted data, or it would find unencrypted data and would alert you on that. And what we also did, we came up with a so-called data lake. So all the data that the so-called security node is collecting will make its way into a data lake. This will be completely anonymized. So what is left over are only tokens, not data. And this is good enough to do behavioral analysis and then alert on if something happens. So we can see if something is misused. And you could see that as well. But most of our customers have a team that is not big enough or is not trained enough to look into API data, which is completely normal because API is a bit new, and API security, as I said before, API security is tricky, and we are at the beginning of understanding what needs to be done within API security. So what we provide is a team that helps you with visibility, with investigation, and with threat hunting. That's why we call it the threat hunting team. And it's part of Akamai's services to provide you better security. So why would you need API security? To rehearse here, on the left-hand side, we start with web security. So in detail, it's web application and API protection. And this focuses on external threats. This is for business to customer only. What we're using here is signatures and machine learning. And we would find DDoS attacks, we would find bots, we would find something that is trying to break your web security by using a web application firewall. We are also having an API firewall that blocks out unauthorized connections, and we would only leave through the good connection. So this is done by the API gateway. At the same time, the API gateway allows partners to connect to your services. But there is something that is bypassing the API gateway. So this is whitelisted, which is mostly for developers setting up new servers and testing it out, and they need something that bypasses the API gateway. Normally, this is also in the internet, and if somebody finds it, there's an easy way to get into your security. So API security from Akamai is addressing all of that. It would look into all of the traffic, into the east-west traffic, but also into the north-south traffic. So this traffic inside your premises, but also the traffic coming from the outside and going to the outside. It does a complete discovery of all of the APIs in any environment. It checks against the OWASP API top 10, so looks for risk postures, misconfigurations, but also looks for behaviors. So it understands every API user behavior, and with that, it can detect the abuse of an API. If you're seeing any alert, then you need to look into that. So you have to perform investigations and threat hunting. And ideally, you would have a team that helps you with that to get a better understanding, faster understanding, and a faster mitigation of the threats. So this is why you need API security to completely secure your APIs. Thank you for your attention. And if you have more questions, please look at the Akamai website. We are providing much more information there. You can record, or you can take a look into the presentation that can be sent to you, where we provide more information about that. Thank you very much.